First, we developed and tested our coding using walkway simulation before implementing it on the actual hardware. In this section, we defined the hardware pin connection between the ESP32 and the components. The ultrasonic sensor trigger and echo pins are connected to GPIO 5 and GPIO 18, while the green, yellow, and red LEDs are connected to GPIO 12, 13, and 14. The buzzer is connected to GPIO 27. We also set the dustbin calibration values, where 35 centimeters represent an empty dustbin and 10 centimeters represent the full condition. This path displays a startup message, then repeatedly triggers the ultrasonic sensor, measures the echo duration, and converts it into distance. The program also limits the readings to the calibrated range and keeps the fill percentage between 0 and 100%. This coding here displays the distance and fill percentage on the serial monitor. It then controls the LEDs based on the fill level, while the buzzer activates at 90% and above. The system updates every 1 second. Next, we demonstrate the operation of our smart dustbin monitor using walkway simulation. Initially, the dustbin level is 0%. Therefore, the green LED turns on, indicating that the dustbin is empty and at a safe level. When we change the ultrasonic sensor distance to 27 cm, the serial monitor displays a fill level of 31%. The green LED remains on because the level is still below 50%. Next, we reduce the distance to 50 centimeters. The fill level increases to 79%, so the yellow LED turns on, indicating that the dustbin is more than half full. When the distance is reduced to 4 cm, the system displays a fill level of 100%. The red LED turns on and the buzzer sounds, indicating that the dustbin is full and needs to be emptied. After that, we increase the distance back to 15 centimeters. The fill level decreases to 79%. The yellow LED turns on again and the buzzer switches off. When the distance increases back to 27 centimeters, the fill level decreases to 31% and the green LED turns on again. Finally, we gradually reduce the ultrasonic sensor distance from 30 centimeters to 7 centimeters. As the distance decreases, the fill percentage gradually increases. The indicator changes from green to yellow and then red, while the buzzer activates when the dustbin reaches the critical level. This demonstrates that the simulation responds correctly to changes in the rubbish level.
Hello and salam sejahtera. My name is Shelven Alidis dan di sini adalah full source code bagi project Smart Dustbin Monitor kami. Dan di sini kami telah menetapkan Blink Cloud Configuration, hardware mapping punya ESP32, serta core logic bagi pengiraan kapasiti sampah. Sekarang kita akan melihat verification yang berjaya untuk coding ini. Dan untuk sebelum itu kami akan go through a full source code ini. Untuk highlight, ini adalah kaki trigger untuk ultrasonic sensor yang kami sambung kepada GPIO 5 pada bahagian ESP32. Dan untuk echo ultrasonic kami sambung kepada GPIO 18. Untuk LED green 12, yellow 13, red 14, dan buzzer 27 pada GPIO 32, ESP32. Next, kita akan verify. Kita akan tunggu sampai 100% verification. Selesai compile, seperti yang dipaparkan pada output konsol di bawah ini, kod telah pun berjaya disahkan dengan done compiling status tanpa sebarang error. This means coding ini telah pun berjaya dan dapat detect dia punya output. Then kita akan upload compiling lagi. Untuk step ini kita akan masukkan program ini ke ESP32 microcontroller dengan uh, tekan upload pada ESP, dan bila selesai proses dia akan menunjukkan status dan uploading lah, yang bermaksud hardware ini telah berjaya dan sedia dioperasi. Dan uploading. Next, bila kita tengok serial monitor, kita akan nampak first state, di mana empty state ni adalah fasa pertama apabila paras sampah masih rendah, dan akan dia kesan jarak yang jauh, serial monitor akan papar status empty dan sistem akan aktif green LED lah. Ini akan kita nampak pada hardware dia nanti. Seterusnya, bila sampah mula bertambah, ini bermaksud fill percentage dia akan cecah lingkungan 50 hingga 79% ataupun peratus. Dalam sistem ini dia memasuki fasa half full, yang dimana monitor bertukar secara real time dan yellow LED pula akan menyala. Kita akan nampak di bawah dia menyala sebagai half, tapi dia tidak dapat turun kalau tidak kena scroll down. So yeah, this is the real time output for half full. Then akhir sekali bila fasa full capacity, sampah dia ni melebihi tahap 80%, status akan bertukar kepada full capacity dan LED merah diaktifkan. Jadi memandangkan sampah telah melebihi 90% penuh dan buzzer turut berbunyi sebagai output untuk warning lah. So pada masa yang sama, semua data kritikal ini akan kena push secara live kepada Blink IoT dashboard kami nanti, yang akan dipaparkan kemudian.
This is the hardware setup of the Smart Dustbin monitoring system. The prototype consists of an ESP32 microcontroller, ultrasonic sensor, LED indicators, and a buzzer. These components work together to monitor the dustbin fill level and provide a real-time status updates. Next, this is the monitoring dashboard displayed on the laptop. The dashboard shows the measure distance, estimated bin level, and the current dustbin status in real time. The data is transmitted to the ESP32's built-in Wi-Fi, allowing users to monitor the dustbin remotely. Now, this is the smart dustbin prototype. The ultrasonic sensor installed inside the dustbin continuously measures the distance between the sensor and the waste surface to determine the current fill level. First, I will demonstrate the green state, which indicates that the dustbin is empty. The measured distance is within the empty threshold, so the green LED is illuminated. The yellow and the red LED remain off. The buzzer is inactive and the dashboard displays the status as empty. Next is the yellow state, which indicates that the dustbin is nearly full. As the waste level increases and reaches the predefined threshold, the yellow LED turns on while the green LED turns off. The dashboard updates the status to nearly full, notifying users that the dustbin should be emptied soon. Finally, this is the red state, which indicates that the dustbin has reached full capacity. The red LED turns on and the buzzer is activated to provide an audible alert. At the same time, the dashboard updates the status to full, informing users that immediate waste collection is required. Lastly, I will demonstrate two operating conditions, one with the dustbin at full capacity and another one with available space inside the dustbin. As the waste level changes, the system automatically updates the LED indicators, buzzer, and the monitoring dashboard in real time. This demonstrates that the smart dustbin can accurately detect the field level and provide reliable local and remote monitoring.